All right, had to start over there for a second, sorry. Recall that the series is the sum of a sequence. And what that means, obviously sum means addition. Sum means to add things up. And so if you think about some sort of series where we might have 5, let me give some room here, 7, 9, 11. This is a sequence of numbers. If we have commas in the middle, this is an arithmetic sequence because we're adding 2 every time. And we probably have a ... saying that this goes on for forever. An arithmetic series has one difference. Instead of commas, we have pluses. Now, if we have the ... and we're going to add things up that goes on for infinity, we're going to likely get infinity as an answer. And so most of the time, we will not necessarily see a ... on the end of a pattern. Anyways, this would be S4 for the sum of the first 4 in the pattern. And it literally just means add these up, okay? You add them up, you get 32. That's how it goes. Now, there's a formula for this. The formula would be the sum of however many you want, right? N is that number that we want, is going to be a fraction of n over 2, and then in the parentheses here, it's a 1 plus a n. And the truth is that this formula shouldn't be very hard to use, right? I mean, we know that a 1 is term 1. We know that a n, it would be term n, or the final term that we're talking about. And that n would be whatever number we're trying to add up. So if we're going to do just an example question, and we're going to solve the exact same answer, 32, but using the formula this time, instead of doing it kind of just the brute force method, the way this would look is it would be sum of the first 4 is going to be n, which is 4, divided by 2 of the first one, which is 5, and then a n, which is a4, which is the 4th term, which is 11. We do this, and we get 11 plus 5 is 16, times 4 is 64, divided by 2 is equal to 32. So this is just a little bit of proof that the formula works. We know that n is the number of terms that we're adding. A1 is the first term. And an is the final term, right? Because if we're adding the first 4 of them together, then a4 would be the final term that we're adding them up. Now, we run into a bit of a problem, though, okay? Because if you remember, this an had its own formula. And if you're taking these notes, I would really recommend that you write this. If you remember, an is equal to a1 plus d times n minus 1. This is a formula that we did yesterday. The truth is that this formula is the hardest formula that we have to do because sometimes we won't be given an, right? In my little example here, it was a piece of cake. Add the first 4. You already have 4. You might as well just add them up the old school method. You're not saving a whole bunch of time here, right? But if I change this question up and I say, what is the sum of the first 14? Now, I could carry the pattern on, add up the first 14 with like a brute force method. Or if I was going to use the shortcut, I still couldn't even really use the formula because I wouldn't know what the 14th term is. I would have to first go and find the 14th term, and then I could use the formula. So it's almost like a formula you have to do in order to use another formula, which can be pretty frustrating. So let's see that in action, okay? For number 13, this is an arithmetic series. We have an arithmetic sequence that goes on forever, but we have the pluses, we're looking to do the sum of the first 10. You got two options. You can either carry out the pattern until you get 10 things, and then you can just add them all up, or you can do the formula. Let's not do the brute force method. Let's practice using the formula. So that means I would need the sum of the first 10 things, which is 10 over 2, parentheses, the first term plus the final term. But here's the issue. I don't know what the final term is, okay? This is exactly what I was just telling you about. I don't know what that 10th term is. And so I have two options now. I can just go and get it the brute force. I said it backwards like 3 times now. The brute force way and just add 2, add 2, add 2, add 2. Or I can come down here and I can use a different formula first. I can find the A10, the 10th term, by doing first term plus the difference times 10 minus 1. And remember, the whole point of this is that it needs to go into this slot. It's one formula in order to use a second formula, and it is a little bit annoying, right? 10 minus 1 is 9. 9 times 2 is 18. 2 plus 18 is 20. And so 20 should go here. And now we're able to solve this. And you can type it in Desmos. 2 plus 20 is 22. 22 times 10 is 220. 220 divided by 2 is equal to 110. And so just to be extra clear, that 110 is the first 10 numbers in the pattern added together. Now, totally another option is to just do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's term 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus. Get a calculator out, crunch all these numbers. It's going to be 110. Okay, I like the formula better because I don't like writing out a million numbers in a row because I can be prone to make mistakes when I do it that way. So I would rather use the two formulas, even though it's a little annoying. Number 14 is very similar. We need to find the 8th term in order so that we can do the 8th sum. So to start off, I know that the sum of the first 8 is going to be 8 divided by 2 of the first term, which is -6, plus the final term. Yet again, I don't know what the final term is. I don't know what the 8th term is. I could try to just continue the pattern to find the 8th term, or I could use the formula. The formula would be term 8 is the first term. I know that this is going to be 8 minus 1, but I need to find the difference. The difference for this question, I can always do, second term minus the first term. And that tells me it's going to be -13. And then I could solve this, get my 8th term, plug it in up here, right? Let's just use Desmos to do this because I'm not confident doing this in my head. -6 minus 13 times 7. Go to Desmos. -6 minus 13 times 8 minus 1. And I get -97. So that tells me that my 8th term is -97, which tells me that right here I need -97. Now I can do this formula up here. And again, let's use Desmos for this. 6 minus -97. So that would be a fraction, which is 8, parentheses, -6 minus 97 over 2. And I've got -412. Let's make sure that's right. -6 plus -97 times 8 divided by 2. Perfect. -412. It's pretty much all the same pieces we already know how to find. It's just one new formula to do one small different thing here, which is add up the series, add up the sequence, which makes it a series. Now, the last thing we're going to talk about on these notes is handling this thing. And this is a really, really, really easy question that is guaranteed to be on the SOL, that is guaranteed to be on your test, that you will have no idea how to solve unless you pay attention for about 2 minutes, okay? What this is this is technically called sigma. I don't know if you've seen that at like a fraternity movie or some sort of sorority thing, but this is a Greek letter sigma, which looks like an E kind of, but it's actually kind of like the S. And so it's an S for sum. This is how we're going to calculate the sum. Okay, what this means is that we basically have a start number here, an end number here, and then this is the formula over here. So what we would need to do is start at 1, plug it in, and do 6 times 1 minus 4, and that will tell us the first number in the pattern, which is 2. Then we would need to take it and plug in the next number until we get to the end number. So we would need to do 6 times 2 minus 4 is equal to 8. 6 times 3 minus 4, which is equal to 14. 6 times 4 minus 4. And we would need to go all the way down to 6 times 12 minus 4. And then we would need to add up all these things. Add them up, 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 add them up. Now, here's the deal. This is going to be very annoying. This is going to be a whole lot of work, okay? What you can do is just type this in Desmos, okay? Desmos will solve the entire thing for you, but you have to know how to type it in Desmos, okay? So the first thing is we need to find this E, which is not really an E, but we need to find the sigma in Desmos. So this is pretty important. We don't really need the graph here. Go to the keyboard. Go to the functions. It's not trig. It's not stats. Oh, accidentally closed my keyboard there. It's not a distribution. It would be miscellaneous, and you can see under functions miscellaneous the giant E. And again, it's not really an E. When you have this sigma notation, it's going to give you those 3 spots: the start spot, the end spot, and the what did I call it? The function, the formula. So in the start spot, we need a 1, and the end spot, we need a 12, and then in the function part, we need 6x minus 4. We don't need parentheses, but it's a good idea. Good idea just to make it look exactly the same way. Nice side. The truth is, Jameer, is that calculators struggle with this a little bit, but Desmos is smart enough that it can handle it. Like, for example, without parentheses, a normal calculator would like ignore the -4 until the very end. But Desmos knows that -4 is part of the formula. But it's a good idea, yeah. Definitely, let's throw the parentheses on there just to be sure. Now you'll notice I've typed it in and I don't have any answer. Right? The answer should be a number, and it should be a big number, right? Because if we look at what we got here, it should be 2 plus 8 plus 14 plus 20 plus 26 plus 32. It should be a number that's like 100 or maybe 200 or maybe 300. Going back to Desmos, the problem is that Desmos is always going to start you out with an N. And the problem is Desmos is trying to plug the 1 into an N, but there's no N. So you need to make these two variables match. You can change either one. You can make them both X's, or you can make them both N's, right? I mean, it doesn't matter. You just need to be the same letter, right? You can literally make them W's, I'm pretty sure. Yeah, okay. So as long as these two letters match, it's as simple as that. Desmos tells you the answer, and you're done. And that's the whole thing, right? That is the sum of the first 12 things generated by this formula. You don't have to do this, just to be clear. This was all just me showing you what Desmos is going to do. Okay, all this work that's going to take you 3 minutes, Desmos can literally do in less than a millisecond, right? I mean, it's going to do it instantly. So let's type in 16. Make sure that you're doing it right. Again, the M's are not important. It can be an M or an X or an N or a W or a J. Just make sure that they match for sure. Type in number 16, then we'll be done. Functions, miscellaneous, one of these. I need 8 and 17. 8 and 17. I'll leave it as an N. Negative 2n plus 3. Negative 2n plus 3. And again, let's go ahead and slap some parentheses on there just to be extra sure. I got negative 220. What do you think? Cool. Negative 220. And again, guaranteed to be on the SOL test, guaranteed to be on your test this week. So easy. You are literally just typing it into Desmos and you're done. That's it for Arithmetic Series. Okay, I'll tell you right now, we're going to get a geometric series formula, which is easier. Okay, this one is the hardest formula because of this little interaction here. Okay, we don't always know what this final term is, so we need a second formula from yesterday to help us find the formula we really want. All that being said, hope series isn't too bad. Hope that this, and by the way, worth mentioning right before I log off, this is also called summation, probably 2 M's. Summation notation at times. You'll also see it like that. Sigma notation, summation notation, it's all the same. All right, that's it.